The CVCA Leviathan robot is an ocean-cleaning monster with a control system that lets it eat trash at a ferocious pace. We started the control design by creating a spreadsheet where we assigned each action that the robot needed to perform with an actuator, which is a motor or servo, and assigned one or more controls, which are joysticks or buttons, to the actuator. We also used the spreadsheet to keep track of the different channels that each actuator and control were assigned to. The controls and actions of our robot are a mixture of motor and servo actuators, and joystick and button inputs. The vertical movement of the arm is controlled by the motor connected to port 2. The motor is controlled by the joystick, which allows the motor speed to be controlled more precisely than buttons would, which would only allow the arm to raise or lower at a fixed speed. The deadband block helps to make sure that when the driver lets go of the joystick, the motor shuts off completely. The joystick isn't perfect, so without the deadband block, when the driver releases the joystick, the motor would still try to move the arm and heat up. The -1 gain block reverses the direction of the arm movement, which the driver preferred. The arm extension and drive motors work the same way as the arm up and down. The wrist control was originally just a motor drive that used a joystick to move the wrist up and down. However, the wrist was too heavy to hold its own weight up, so we added a bias to the wrist motor input. That was enough for the wrist to keep from dropping on its own, but put a lot of load on the motor. So we added a potentiometer to the wrist so that we could measure its position using one of the VEX analog inputs. We used that signal to create a feedback control using the Simulink PID block. We turned the controller to make the wrist response stable by changing the proportional and integral parameters in the PID block. The robot uses several servos to release a counterweight, the scoop dump, and the box grabber. All the servos work with latched buttons. We wrote a custom block to let us adjust the servo angle limits easily. This block was written as a subsystem. A Simulink mask was created for the subsystem, with edit controls to let the programmer adjust the maximum and minimum angles for the servo. The block was put into a custom Simulink library so we could reuse it in other parts of the program. The simple programming environment that Simulink provides has allowed us to write a sophisticated control system for the CVCA Leviathan, which gives us the controllability and the flexibility to create a winning robot.
Thank you!